Facial ratio. It all starts with 1.618, also known as the golden ratio.
1 to 1.618 is used in facial ratio as found in the ratio of the eyes to the nose and the pupils to the teeth to the chin. This led to Dr. Marquardt creating a perfect face mask which is used in facial beauty. We recreated the mask by drawing the golden decagon using golden ratio.
Whoa, these filters are so cool. Have you tried them out?
Yeah, but how do they work?
I think they work using facial ratio.
Snapchat uses facial recognition to map points on your face to create a mesh which is then used for filters.
Facial recognition.
Facial recognition works by something called computer vision.
But what's the maths behind it?
In 2001, the Viola-Jones algorithm was created by Michael Jones and Paul Viola to develop facial recognition software.
The algorithm is used for facial detection. It has 4 stages: half feature selection, creating an integral image, AdaBoost training, and cascading classifiers.
The algorithm first uses half features, several different features which compare the light and dark areas of the image to determine whether it is a face or not.
The same technique is applied to face detection. For example, this feature shows that the bridge of the nose is lighter than the eyes on either side.
The algorithm then generates a sum of values in a grid, known as the integral image.
This is the algorithm. It means that the value at xy in the grid is the sum of the pixels above and to the left of it, where xy is the value of the pixel at xy.
Now that's a lot of maths to calculate, so let's give an example so it's easier to understand.
Each number represents a pixel in the image. The algorithm calculates the sum of pixels above and to the left, so let's add up to create what's called our integral image.
So 17, for example, is the sum of the numbers in the red square, 26 is the sum of the green box, 68 is the sum of the blue box, and 113 is the sum of all the numbers in the grid.
This is called machine learning, and the most commonly used algorithm used for this is called AdaBoost. It works by turning weaker classifiers into stronger classifiers that can easily separate terms accurately.
The next step is using cascade classifiers. Classification means putting objects into classes based on some property they have. For example, an image of a duck is put into the system which is classifying ducks. It will go through the computer, which will perform a series of tests to see whether the duck is a duck or not.
It's exactly the same with cascade classifiers. The image goes into the system which performs the first test to see whether it's a face or not. If it fails this test, the image is not a face. If it passes the test, it will continue to the next 100 or so tests until the only images left are faces.
Local binary patterns are used to recognize differences between pixels to generalize what a face looks like using 8-bit binary. The numbers in the left grid, representing pixel brightness, are converted into ones and zeros, which the computer can then read.
We got in contact with Tony Porter, the surveillance camera commissioner for the Met Police, and he said that, quote, "The algorithm allows a video image to cross-check against that list and perhaps identify someone in it, perhaps a criminal who is wanted by police."
For our final product, we have used a program which detects each face in a group photo and labels them with their age, gender and emotion.